Hello, so we're live once again, and as I said yesterday, I would have finished the documentation on delegated properties today and type aliases, so I will just dive into it. If you haven't already, you can follow yesterday live stream, and yeah, at some point I couldn't manage to do it anymore because I was a little bit tired. So let's carry on with it today that we have a little bit of a fresher mind. So we were stuck here on property delegate requirements, and we had started to read this, but basically what it says is that for a read-only property, like value, a delegate should provide an operator function with the get value and with the following parameters: thisref, which must be the same type or as a supertype of the property owner, and then the property itself must be of type kProperty, and so basically of any, or its supertype, and then get value must return the same type as the property. So, for example, here, what we have is we have our resource, then we have our owner, so the owner of the resource, and we have our value, which is a resource, but it is delegate. The computation of the get is delegated to resource delegate, and this means that we need to create a class with the get value with this signature, and this must return a resource. And this works fine. I think we did something similar yesterday. Maybe not here, but here. So we have our our delegate here, and we have this ref property over here, and this is a variable because if you do it with if you do it with a variable instead of a value, you also need to define the set value. As you can see here, it will complain it if it's not set up. So this is something we have already done. And then this is saying basically that for mutable properties, you need also the set value. So get and set can be provided either as member functions of the delegate class or as an extension functions. Both the functions need to be marked with the operator keyword, and you can create delegates as anonymous objects without creating new classes by using the interfaces read-only property and read-write property from Kotlin library. They provide the required methods. Get value is declared in read-only property, and read-write property extends it and adds set value. This means you can pass read-write property whenever, and read property is expected. So this is very useful because you could have another delegate example, but in this case we'll have actually a function. So yeah, let's try and define it from scratch. So let's go back. Delegate property standard, let's call it. And so here we have our function resource delegate. I don't know why it's always making a mess here when I scroll. Okay. So we have our function resource delegate. And yeah, we also need to create our resource. Yeah. Our resource and our owner is not required. Only resource. Okay, and then you import from Kotlin. Import from Kotlin. Okay. So what we have done here is we have created a function in which we pass a resource and we create the resource class, but resource delegate is a function actually, which returns a read-write property, and this function specifically is going to return an object which is read-write property, is of type read-write property. So we're implementing an interface for this object, and we are setting the get and set value. We are overriding, sorry, the get value and set value functions in order to return a certain value, which in this case is actually the resource. And if we want to set it, we just say current value equals to value. So we're setting the resource. And so this will work to have a resource which delegates as a variable value, which delegates to this function, and a read-write resource which delegates still to this function as well, without the need of having two separate delegates for these two properties. So that might be useful in some cases. We could also run it over here. We have to take these values like yeah, we have to put them inside the companion object. So companion object. Oops. And here we go. And here. So we need to, in case we want to change the value, we can do so. Like, let's create here default, and then let's have here custom. So now what we can expect is that in the first case we will have our read-only property printed, as as default, and then we'll see that we can do both, like read from read-only or read from read-write. It shouldn't matter. Let's try and run it. So what I've done, oh, okay. I need to print this as a message. All right, so yeah, sorry, I was missing this one as well. So yeah, now as you can see, our read-only resource is having default as a value, and our custom resource instead, which our read-write resource, which in which the value was changed, is now behaving with the new resource and giving us the proper message. So next, let's see what we have to read. So the get and set functions can be provided either as member functions or of the delegate class or an extension function. The latter is handy when you need to delegate a property to an object that doesn't originally provide these functions. Both of the functions need to be marked with the operator keyword. And I think we already read this, sorry. I am yeah, because this was from, yeah, okay, we already read that. So let's go to translation rules for delegate properties. Under the hood, the Kotlin compiler generates auxiliary properties for some kind of delegated properties and then delegates to them. For optimization purposes, the compiler does not generate auxiliary properties in several cases. Learn more about delegating to another property. For example, the property prop, it generates the hidden property prop delegate, and the code of the successor simply delegates to this additional property. So basically, under the hood, this code is generated when you do the delegation. It creates a private value with a default value, and then it creates two getter and setter methods, one to get the value and one to set the value, of course. And the Kotlin compiler provides all the information about property in their arguments. The first argument, this refers to an instance of the author class C, and this prop is a reflection object of the K property type describing property itself. So let's see. Yeah. Then so this should be clear. It's just generated code for delegation. Then we have this this statement here, but I prefer to read it from ChatGPT, which has documented on it a little bit more. So this documentation refers to the limitations made by the compiler for delegate properties, especially when the compiler can omit the generation of delegate field in the class. So normally when you use a delegate property like a delegate property like value s string by delegate, Kotlin creates a hidden field delegate, which we've just read this, and this field is used when calling get value or set value. And so when a delegate is not needed, Kotlin skips it in some cases to optimize memory and bytecode size. And here are those cases. So the first one is reference property, and we see it here. You are delegating directly to an existing property. So using the two columns operator, no need to store a new delegate instance. It can be resolved at runtime by reference. So this will reference to the existing property, and it will not make create any getter or setter because it will use this variables implementation, getter and setter. So for example, this might be useful when you want to have a private property and want to delegate the external property, let's say the public property, to it. Named object. So yeah, this might work as if you want to have two names for the same property or want to do some fancy things. Then we have named objects. So if you use an object, this is a singleton object, and there's no need to store it in the class. The compiler knows where it is globally. So this object will eventually work as a getter or setter, I believe. Yeah, in this case, only as a getter because we have a value. Final value with backing field in the same module. So we have a backing field implementation, and we have a value. So if implementation is a value, so the backing field is a value, and known at compile time within the same module, so it has to be inside the same module, the compiler knows it and won't change and can directly access it without creating delegate field in A. So it can reference directly the implementation property that we have created here. Constant expressions, this and null and entries. So, well, as by this, so this is a constant inside the class. And here this is always the same and available at compile time. And so there is no need to store the delegate. So avoiding delegate means less memory usage, smaller class files, potentially performance gains. Okay, that's good. Now we have read this, and we're going to translation rules when delegating to another property. So the translation rules, I will read them also from here. This is a feature you're asking about, and it's called provide delegate. And this is an advanced feature that lets you customize what happens when a delegate property is declared. So let's break it down. When you write vol myprop by some delegate, Kotlin does two things. It creates a backing field and uses get and set. So we have already read this. And what provide delegate does, when some delegate defines a provide delegate, Kotlin will call that function first before creating delegate field. This gives you a chance to validate, wrap and transform the delegate at property declaration time. So example use is property name validation. So this is our resource. We have our provide delegate, and we have a read-only property in this case. So we're returning resource delegate here. And what we're doing is we're checking property name, for example. So in this case, we can write val by image by bind resource image, resource id.image. And in this case, we don't need to repeat the image because we are checking, yeah, this check property. Let me see. Is a function which probably checks if this is an instance of property name. Yeah, sorry. If it will probably check if my UI and the value that you're trying to set is fine. So you don't need to pass image, which is the name of our resource, of our value. Maybe I will try to have some more explanation on this. So if provide delegate exists, the compiler generates this. So it provides it will generate a delegate $delegate value. If it doesn't exist, it just calls my delegate. So provide delegate intercepts the creation of the delegate, but it doesn't change how get and set value works. It's a purely setup time customization hook. So yeah, this is some fancy stuff to detect the, as it says here, to detect intercept the creation of the delegate, and it's purely a setup customization hook, so I don't think we need to go further in details with this. Kotlin offers this helper to avoid creating a custom class for the provider. So it's a shortcut to build and return a delegate based on the property name type at declaration time. So when you should use it to validate property names, types at declaration, apply dynamic logic when binding, inject logging, configure metadata, or avoid repetitive code in declarations. Okay, so this is a little bit more advanced. So this was translation rules. Let me check. I skipped something. Yeah, so that's it. So that's it for the delegation. I think the initial part was the most interesting part. So like what we've seen yesterday. And now let's skip to type aliases. We have already done some few things with this, so but we will read it very quickly. Type aliases provide alternative names for existing types. If the type name is too long, you can introduce a different shorter name and use the new one instead. So if you have like a mutable map k mutable list of file, you can have file table k, which is shorter, and you might use that. So this is why type alias might be useful, because last time when we used them, we didn't think about this. So type alias, I would say so. Name for existing types, useful to reduce plus, yeah, to reduce length of fields, like in this case. All right. Next, you can provide different aliases for function types. So also a function might be it works with functions. So in this case, we have a function in which we pass a type t and we return a boolean, and this will work to specify this type as well. Next, you have new names for inner and nested class. So okay, we can have the new names like this. I wouldn't say it's very useful. Type aliases don't introduce new types; they are equivalent. So yeah, you can exchange them if you need to because they are the same. So as you see here, we can pass to foo a function like this, or you can also specify the predicate integer if you wish to. So that's pretty much it for today. And I hope you guys enjoyed and have a nice evening and see you on the next one.